3 and 5. So I'm going to give you something similar to them to do, and then you can go back and tweak those problems. Even though they were due yesterday, I still have it open, so you can certainly resubmit them and do it today. So if you have something like this where you have a exponential function times an exponent equals blah, 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 again, we want to go back to creating the same base, right? So again, it always goes back to getting the same base here. So if I look over here at 4, 8, and 16, their same base is 2, which is beautiful. So I can write 4 as 2 squared. And of course, I can raise that to the 5x plus 3 times. I can write 8 as 2 cubed, which I can then write as 6x minus 1. And then this is, let's get crazy. Make it 1/16th, okay? 1/16th. So then that's going to be 1 over 2 to the 4th raised to the 3 minus 8x power, okay? I just changed it to 1/16 so we can make it a little more interesting. So right over here, I know I'm going to want to write this as 2 to the negative 4th. So I have 2 to the negative 4th, which I'm now going to raise to the 3 minus 8x power. And then over here, again, when you raise a power to a power, you multiply your exponents. So we're employing our laws of exponents every single time. So this is 10x plus 6 times 2 to the 18x minus 3. And that's going to be equal to 2 to the negative 12 plus 32x, right? Because I'm distributing that there. But now let's go back over here. When you're taking two bases, when you're multiplying the two bases, remember what you do to the exponents. You don't multiply the exponents, you add the exponents. Remember, if I have a to the x times a to the y, it becomes a to the x plus y. So now over here, I can just go ahead and rewrite this as 2 to the, if I'm going to add my exponents, 10x and 18x is 28x. And then 6 minus 3 is plus 3 is equal to, 2 to the blah, blah, blah. Now that I have the same bases on each side, I can now set the equations equal to each other, right? And I could go ahead and solve for x, which I'm going to skip because, this is just an algebra, a pre-algebra problem. So it'll all work out in the wash. And if you want to go back, and that should be an x here, go back and check it out. We can do something like that. So then let's say, for example, we have 27, 5 minus 2x over 9 to the 1 minus 8x is equal to, let's make it 1 over 81 to the 4 plus 3. Why the heck not? Okay. So again, we're trying to solve this exponential equation, and again, our goal is to get the same base, and if you look at 9, 27, and 81, the same base is going to be 3. Okay, your same base is going to be 3. So again, I'm going to come over here, rewrite 27 as 3 cubed, and noticing I'm always using my laws of exponents to my favor. Again, 9 is going to be 3 squared. We're going to raise that little sucker to the 1 minus 8x power, and then this is going to be 1 over 3 to the 4th raised to the 4 plus 3x. So again, you raise a power to a power, you multiply the exponents. Again, over here, you should be writing this as, yes, 3 to the negative 4. So I'm even going to do 3 to the negative 4 over here, so we can go ahead and raise that to the 4 plus 3x power, so we can cut right to the chase and get our work done here. So now when I raise my power to a power, I'm going to be right over here. So that's going to be 3 to the 15 minus 6x over 3 to the 2 minus 16x. And that's going to be equal to 3 to the negative 16 minus 12x. So now we're looking at this part of the equation. And again, we have the same bases, and when we divide like that, so if I have a to the x over a to the y, the rule tells me that yes I do, I subtract the exponents, so that's what the rule is, okay? So if I come over here, I'm going to subtract the exponents. Now be careful, if I'm subtracting the exponents, I'm subtracting that entire quantity, so therefore I want to use parentheses. So that becomes 3 to the 15 minus 16x minus quantity 2 minus 16x. Okay, and that's going to be equal to 3 to the negative 16 minus 12x. So if I distribute that through, my negative sign through, I get 15 minus 16x plus minus 2, and then plus 16x is equal to 3 to the negative 16 minus 12x. Your 16x is canceled. 15 minus 2 is 13. So now you wind up with 3 to the 13 is equal to 3 to the negative 16 minus 12x. And now you have the same bases, so you can put the two exponent, you can set the two exponents equal to each other. So you have 13 is equal to negative 16 minus 12x. And again, this becomes a simple algebra problem. So now I'm going to tell you guys, I have a feeling some of us need to go back and redo 3 and 5. So why don't you guys go back and do 3 and 5 and redo them and resubmit them. And I don't care if it's considered late or anything like that on Canvas because it's still open. So let's get it done.